Guys, I just found out something terrifying. Those topologists, the ones that get way too excited about holes, right now they're saying that this mug and this donut are the same shape. Let me go get ready and we'll start unpacking the juicy gossip of algebraic topology. Okay, you guys, before you call the math police on me, let me explain. In topology, we don't care about straight edges, we don't care about angles, and we don't care about whether or not something is edible or not. What we do care about, though, is connectivity, holes, and whether or not something can be
squished or stretched, but never being torn or glued.
That kind of shape morphing equivalence is called a homeomorphism. Wow. So if we took the surface of this mug, notice that there's only one hole. Then, if I took the surface of this donut, notice there's only one hole. So, topologically speaking, they have the same hole structure. Boom. Homeomorphism. Wait, I know what you're thinking. But before your brain starts melting like a Krispy Kreme donut, let's first discuss the difference between a donut and a torus. Really quick, your donut is usually full of dough. But when we talk about a torus in topology, of course, it is only the surface of this. So it is hollow. There is no dough on the inside. So here's the crucial distinction. The surface of a donut is the same thing as a hollow torus. But then my mug is supposed to also turn into a hollow torus, which means that my mug must also be the same thing, a hollow torus surface. So when we're comparing things, we're only comparing the surface, right? So essentially, to put this into Gen X terms, it's like watching someone's Instagram story instead of knowing every detail of their life.
Guys, it's time for the real math magic. Ready? We're gonna learn how topologists understand donuts and how they understand
Topologists start by looking at CW complexes. These are zero cells, which are single points. They look something like that when you magnify it. We have one cells. Those are just lines. They can be curvy though, so watch for that. We have two cells. Those can be loops or they could be full surfaces. Then we also have three cells, which are volumes or are three-dimensional shapes. We can go beyond that, but for our purposes, we're only worried about 0 through 3.
You can only use these ingredients in your recipe.
Looking at this set of ingredients, we're going to be using the 0, 1, and 2 cells to make our very own donut and coffee mug. So, if I add in 1 0 cell, 2 1 cells, and 1 2 cell, I'm able to get the CW complex of a torus.
Oh my God!
Now, if I were to take all those things out of the mixing bowl and put them back just in a different order, I would get the same CW complex as my very own coffee mug.
If the recipe's the same, the CW complex has to be the same.
So essentially, we're able to attach different ingredients in different spaces and orders to create donuts and mugs.
Eternity later.
Now imagine I take the surface of this mug and I start squishing it and stretching it and I turn it into a donut. That process is called a deformation retraction. It's kind of like trying to fit everything into a suitcase. You're not really destroying anything, you're just rearranging and hoping it all fits. The donut and mug surfaces also have the same fundamental group, which you could essentially think of this as the algebra of loops of each separate surface.
Welcome back. If you look at a donut and a mug, you can see a loop that would form around the hole in both objects. There is also a secondary loop that would go through the holes of the objects.
Combine these loops, we get something that looks like pi 1 of our very own donut equal to z cross. And drum roll, please.
same goes for our mug here.
Hey, that's pretty good.
So after all that, the loops, the CW complexes, and the deformation retractions, here's the punchline. This one wakes me up, this one puts me to sleep. Same skeleton, same fundamental group, same squishy core identity. But topologically, they collapse into the same little loop system. So yes, a topologist literally cannot tell the difference between a mug and a donut. One whole things.
They really are sweet.
Thanks for taking the time to watch this video.